Hello friends, good morning. I am Dr. J. Prasad, working as an assistant professor in the Department of Electronics and Communication Engineering of KPR Institute of Engineering and Technology. In today's session, we are going to discuss designing of combination logic circuit using CMOS logic. And these are the content today we are going to discuss. Firstly, we are going to discuss the very basic difference between what is combination and sequential logic circuit. Then we are going to discuss how CMOS logic will be helpful for designing of combination logic circuit. And followed by, we focus three different types of CMOS combination logic, namely static CMOS logic, ratio logic, and dynamic CMOS logic. So the first slide, it explains the very basic difference between what is combination and sequential logic circuit. So basically what do you mean by a combination logic circuit is, it is interconnecting of different logic gate like basic gates, AND gate, OR gate, and NOT gate, and universal gate. And combination means the interconnecting of these number of combination logic circuit to perform of digital signals. And the observation between combination and sequential logic circuit, the combination logic circuit has no feedback connection. Since it has no feedback connection, the output depends upon only present input. And whereas in a sequential logic circuit, the combination logic circuit has a feedback connection. The feedback connection probably either 1-bit memory or n-bit memory. If I need to be connect 1-bit memory, I can go with we can go with latch or flip-flop. If suppose I need to be establish the feedback connection through n-bit memory element, means I need to be connect n-bit shift register. So in today's session, we focused only combination logic circuit. So first of all, let me explain you what you mean by a CMOS combination logic circuit. So basically, CMOS combination will be combination of both NMOS transistor and PMOS transistor fabricated in a single die. So this block diagram explains basic principle of CMOS logic circuit for designing of a combination logic circuit. So the in block V1, V2, it indicates to be an input voltage, and output will be taken across the junction of NMOS transistor and PMOS transistor. So first of all, the CMOS combination block will be comprises of both NMOS transistor and PMOS transistor. And PMOS transistor should be connected to VDD and NMOS transistor connected to VSS. So you might have a question, why we need to be connect PMOS transistor between VDD and output, and why NMOS transistor should be connected between output to VSS. The reason behind it is, say for example, I am taking of P-type transistor, the majority carrier will be positive ion, minority carrier will be negative ions. So if I need to be move the electron on P-type transistor, I need to be connect maximum voltage. Since positive ion will be dominating of electrons in PMOS transistor, in P-type transistor, I need to be connect maximum voltage to P-type transistor. So that is why PMOS transistor connected to VDD, whereas in NMOS transistor, as all we know that the NMOS transistor will be majority ion will be negative ion, minority will be positive ion. So since the electron will be dominating of positive ion, I need to be connect only minimum amount of voltage for NMOS transistor. So that is why NMOS transistor connected to VSS. Correct? The conclusion is the PMOS transistor need of maximum voltage to moving of electron from one location to other location. So that is why PMOS transistor connected to VDD, where a NMOS transistor require of only less biasing voltage. That's why it is connected to VSS. So with this short explanation of basic principle of combination logic circuit, first let me explain you how that a CMOS logic will be, how NMOS transistor and PMOS transistor will be act as a different logic. So first of all, we are going to discuss the effect of NMOS transistor connected in series and parallel. So before that, according to the basic concept, the NMOS transistor will become an on condition, form in a closed switch when input is logic 1. Otherwise, it become an off condition. Okay. So the first representation, it indicate to be two NMOS transistor N1 and N2 are connected in series. So I called 2 point, T it is called to be a transmitter point, T or it is called to be a receiver point. Okay. So let's assume that when the information is connected at transmitter section, if it is reaches to receiver section, then output will be 1. Otherwise output will be 0. And according to that graphical representation, that N1, N2 connected in series. So whatever the information I have connected at transmitter end, it will be reaches to receiver end when both N1 and N2 transistors become to be a closed connection. Otherwise output will be 0. And say for example, kindly look at the table. I placed of input 1, input 2, and based on, since it consists of a 2 input, there are 4 combination will be possible: 0 0, 0 1, 1 0, and 1 1. So say for example, I am taking first combination input 1 and input 2, both will be at low level 0. So both transistor become an off condition. So the information whatever I connected at transmitter end, it should not be reaches to receiver end. So I called output will be 0. For second combination, only N2 become an on condition, but the transmit, since N1 will be off condition, information should not be reaches to receiver end. The same condition for second and third combination. When both input comes to be equal to one condition, both N1 and N2 transistor become an on condition. So the whatever information we have connected at transmitter end, it will be reaches to receiver end. So output I call to be 1. Okay. So actually this is the truth table satisfying of AND gate. So what will be the conclusion is, if two NMOS transistors connected in series, it will be act as an AND function. Okay. Likewise, the second diagram it explains the two transistors N1 and N2 are connected in parallel. Okay. So there are two paths will be exist since both will be connected in parallel. So the information what I connected in T, it may be reaches to receiver end either transistor of N1 or either through transistor of N2. Otherwise both transistors become an on connection also, it will be reaches to receiver end. Okay. So first combination, since it will be two input combination, I listed four combination 0 0 0 1 1 0 1 1. Correct. For first combination, when both input are 0, both N1 and N2 transistor will be off condition. So both transistors, since both will be an open connection, the output will be 0. For rest of followed by two combination like 0 1 1 0, out of N1 and N2, one of the transistor become an on connection. So the input will be transmitter end will be connected to receiver end. So output I call to be 1. For the last combination, when both input are equal to 1, both N1 and N2 will be on connection. So the information whatever I connected transmitter end, it will be reaches to receiver end. So output I call to be 1. Okay. So from the truth table, from the simple from the operation table, it is observed that the output will be satisfied with 0 for when both input are 0. Otherwise output will be 1, which is satisfying of OR connection. So the conclusion is, when two NMOS transistors connected in parallel, it produces an OR function. Likewise, here is the schematic representation for PMOS transistor connected in series and parallel. And before that, the basic concept of PMOS transistor for digital logic, it says that when logic 0, the PMOS transistor become an on condition. When logic 1, the output will be, the transistor become an off condition. So with this short principle, with the short note, I am explaining you how the effect of PMOS transistor series and parallel connection. So the P1, P2, the first condition, P1, P2 are connected in series. Since it will be two input combination, I listed four combinations. Okay, first combination for 0 0. So both transistors become an on connection. So the information what I connected at transmitter end, the information what I connected in transmitter end, it reaches to receiver end. So I called output will be 1. For rest of the two combination for 0 1 1 0, either P1 is connected or P2 is connected. So there is no direct path exists from transmitter to receiver. So output I call to be 0. For the last combination, when both input are equal to 1, both transistor become an off connection. So the output I call to be 0. So the conclusion, when PMOS transistor connected in series, it acts as an OR function. When two PMOS transistor connected in parallel, the two path will be exist either through transistor P2, either through transistor P1, between T2 or transmitter to receiver. Correct. When input 0 0, both transistors are on connection, two paths are exist. So through either due to the switching speed, either through transistor P1 or P2, T will be connected to receiver. So I called output will be 1. of the combination 0, 1, 1, 0, since both will be connected in parallel, either P1 will be connected or P2 will be connected. So somehow whatever information we have connected at T will be reaches to receiver. So I called output will be 1. When both input are equal to 1, the both transistor become an off connection. So the transistor will be, both transistor become an off connection. So input will be not receiver to receiver end. So I called output will be 0. So the conclusion is to when two PMOS transistor connected in parallel, it acts as an NAND function. So here are the, so far we have discussed the basic principle of a combination logic circuit, the CMOS, which is nothing but base combination of NMOS and PMOS transistor, and also we discussed the effect of NMOS transistor and PMOS transistor connected in series and parallel connection. So we conclude that when two NMOS transistors are connected in series, it acts as an AND function. When both are connected in parallel, it acts as an OR gate. Likewise, when PMOS transistor are connected in series, it acts as an OR function. When it is connected in parallel, it acts as an AND gate. So with this principle, with this summary, we are going to discuss different type of a combination logic circuit. So actually these are the basic classification of a combination logic circuit using CMOS logic, and out of these logic we focused static, ratio and dynamic logic circuit. Thank you. With this I conclude this topic. Different type of static CMOS logic we will discuss in next session. Thank you.